In this lesson, we are going to find the area bounded by the curve and the axis. So we have a curve here that's above the x-axis, and we're going to find the area bounded by this curve, y equals to x squared plus 1, and the x-axis from the upper limit of 2 to negative 2. So the area we are finding is this shaded area here. To find the area, we will use definite integral. So we'll integrate x squared plus 1 dx from 2 to negative 2. So we will add the power by 1, and we will divide by the new power, plus 1 will become x, because this is x power 0, so we add the power by 1, so it will be x power 1 over 1, which is just x, and we'll integrate from 2 to negative 2. Substituting the value of 2 in, we will have 8 over 3 plus 2. Substituting the value of negative 2 inside, we will have negative 8 over 3 minus 2. And we are supposed to subtract these two values, and we see that the area will be 28 over 3 square units. So we realize that the area is positive. Okay, so when we integrate a curve that's above the x-axis, okay, the value of the area will be positive. Now, what happens if the curve is below the x-axis? So we'll find the area bounded by the curve, the x-axis, and the upper limit will be 2, the lower limit will be negative 2. The area will be this shaded region here. So I'm going to integrate from 2 to negative 2. This new function here, negative x squared minus 1 dx. So we will add the power by 1, divided by the new power, and 1 will become x. So we will have minus 1 will become minus x. And we will integrate from 2 to negative 2. Substituting in the value of 2, we will have negative 8 over 3 minus 2. Substituting the value of negative 2 into this term here, we will have 8 over 3 plus 2. Remembering, we will have to subtract these two values. That will give us negative 28 over 3. Now we realize that area cannot be negative, so we need to make some slight amendments to these whole steps here. So area must be positive, and in order to do that, I will need to add a negative for each steps. Now what this means is that in order to find the area bounded by the curve that is below the x-axis, we will need to add the negative sign before we integrate. What happens if we are finding the area bounded by the curve and the y-axis, and the curve or the area is on the right side of the y-axis? So this will be the area here. So let's take a look. I will integrate this function here, y squared. Now notice the x is the subject now. Okay, and we will integrate y squared with respect to dy from 2 to negative 2. We will add the power by 1 divided by the new power from 2 to negative 2. So if we are finding the area between the curve and the y-axis, you must make sure that the function has x as the subject. If we sub in the value of 2, we will have 8 over 3. If we sub in the value of negative 2, we will have negative 8 over 3. And once again, we must subtract these two values, and that will give us 8 over 3 plus 8 over 3, which is 16 over 3. We realize that the area is now positive and we do not need to do anything when we are integrating Fy with respect to dy if the curve is on the right side of the y-axis. Finally, what happens if the curve is on the left side of the y-axis? So we will integrate from 2 to negative 2. This new function here, negative y square dy. We will add the power by 1 divided by the new power from 2 to negative 2. So if we sub in the value of 2, we will have negative 8 over 3. If we sub in the value of negative 2, we will have 8 over 3. We will minus these two values, and that will give us negative 16 over 3. You realize that now the area is negative. So we must change it to positive by adding a negative to every single step. So if the curve is on the left side of the y-axis, we need to add a negative sign before we integrate.